Welcome everyone. I assume a few people are starting to come in. I can see the attendees coming through. Just a few sort of T's and C's and basic functions before we get into it. We have, obviously, for privacy's sake, we don't want sort of your details being exposed out to everyone else. So we have an administrator who will be contacting you privately. And this will give you the option to communicate, send private messages, send questions, and I will put this forward through to our experts that we have on the webinar today to go through and answer as best as they can. And at the end of each problem that we've gotten the solution, what we will do is also open up a poll. We'll give you about 30 seconds to a minute, just again, questions around that specific topic that we are talking about. So, right, enough of that sort of boring stuff. That's sort of the standard protocol. I'd like to welcome everyone to our webinar around sort of the 11 biggest mistakes within tape conversion and medical manufacturing. So it brings me sort of great joy to bring on our two guests today. The first one being Matthew Rich. So Matthew, we speak occasionally. So Matthew has been with PolarSeal. He'll give you a more in-depth introduction. Thanks, Matthew.
That's good. Thanks, Shaun. And good morning to everyone that's joined the call. Thank you for your time, obviously. And hopefully some of our experience shared will be of help to you in the future. But yeah, like I say, I've been with PolarSeal for 10 years now and working from being at machine level and through to get that thorough understanding of the way flexible materials work. Obviously here at PolarSeal, we've long established company in the conversion market, so whether it's adhesive tape or a flexible material, specifically in the medical marketplace, and converting that into a wound dressing or a fixation device or a wearable diagnostic. And yeah, through this 10 years, obviously that's experience that's covered across all the medical products that we produce, convert from materials, and looking forward to sharing some of that. And one of the things, I think a lot of it does come with experience, but we're often told that we are the masters of the art of converting. So hopefully, again, some things that will help others on this call. Thank you for joining.
Brilliant. Thanks, Matthew. Let's bring that sort of master knowledge through to the questions that come through later. Brilliant. And then so the next guest that we have is Phil. Phil Webster comes from DRYTAC. He comes with an extreme wealth of knowledge with over 2 decades, or a quarter of a century in the adhesives sector. Phil, welcome.
Thanks. Thank you, Shaun, and good morning to everybody. I'm Phil Webster. I'm the head of industrial sales for DRYTAC Europe. DRYTAC are an adhesive coating company, and we coat solvent-based, water-based and hot melt pressure-sensitive adhesives onto flexible roll-based materials. Our sort of core business is within the graphics market, but we produce products for the medical market, for security, automotive, and we're involved in a lot of diverse different markets. I've been with DRYTAC now for 7 years, and prior to joining DRYTAC, I've been involved in adhesive sales within the tape and label market, also worked in automotive, and also been involved in adhesive application and coating equipment. So that's me in a nutshell.
It's a big nutshell. Yeah, I mean, Phil, thank you very much again for joining us, and hopefully you can bring that knowledge and more than likely probably educate us on sort of the adhesives and the right application in the right area. So again, thank you very much. So what we will be doing throughout this now is obviously presenting problems and how PolarSeal and DRYTAC, and we've come up with solutions to overcome these. So to begin with, find the buttons here. We don't want to do that. You all know me. So so we're going to begin with tension troubles. I'll happily sort of present these issues and then let the two experts sort of really get down to it in terms of talking about the solutions. So I think one of the first ones that we've come across is sort of the curl in the end product, and I'm sure some of the most experienced people, most of the people on this call will identify this as an issue. And that end product, coming up with a solution of how to prevent curling sort of around the border of the product. And what is this down to? Is this down to the layers, the multi-layers of the dressing or the product, or is this the adhesives? And both the guys will go through that. And then again, going through sort of reduced throughput because of incorrect tensions, and then finding varying levels of adhesion performance. And again, that's kind of where Phil will come in and provide sort of that in-depth knowledge. So moving on to the solutions here, guys, if you want to take the stand here and talk about how you've come up with solutions around product curl.
Yeah, that's good. Like I say, quite a few of the people on this call will be aware of tension and what that can do. It can produce undersized parts or curly parts and affect the adhesion performance. I mean, just starting off with that first one there, product curl can be due to either tension in the initial material, just being stretched through a previous process, or the temperature or humidity of the day that it's running. And the part might come off the line looking absolutely perfect, the right size, tolerance, and then 24 hours later it changes, and then a week later even it can completely change. Obviously that causes a challenge if you're in manufacturing, because you can't wait a week for everything to see how it's going to turn out. So it's very important to get back to that root cause, finding out what it is. Like say, is it due to a lamination issue or a lamination height? And if it is, then working out where you need to add in extra material through nip pressure, and then capturing that information. I think that point that we've got there on training procedures and SOPs, whilst it might seem very basic, once you've done the validation and you've worked out what those tensions need to be at every single station through the process, obviously you then have a repeatable process that you can work to each time.
Brilliant. Yeah, thanks. So Matthew, what do you think about temperature being one of the main effects here, or do you feel that's down to sort of the tension applied to around the application of the product, or is it basically the storage temperature, following up temperature of once it comes off the manufacturing line?
Yep. I'll probably move this on or pass it on to Phil, who's much more on the scientist side of it than I'm. Phil.
Okay, yeah, obviously temperature and humidity can impact the materials, and if you're using paper release liners, they can, if they're stored in a very dry environment, this can introduce curl into the paper. And you've also got expansion and contraction of materials at different temperatures, which again will play around with your tensions and give you some inconsistencies. So we always advise materials are stored in a climate controlled environment to give you that stability and the consistency.
Great. Okay, so those perfect best practices. Thank you, Phil. Perfect. And then sort of moving on through sort of how we've gone about solving these problems.
Yep, absolutely. So it does come back to training. I think I mentioned the comments that we get of having mastered the art. And a lot of people come, and there'll be ones on this call thinking that there's a bit of a black art to converting. And
Is there?
to a certain extent, possibly. But actually, even if there is a black art, that is knowledge transfer, which is something that we very much focus on here. Right. And there are so many technological ways now of replicating something that's worked. So through the equipment, etc., available in a converting process to ensure that once the correct product is coming out, the machine can be broken down and reset up hundreds of times to exactly the same levels. Obviously, there will be a bit of variation in materials depending, as Phil's touched on, the temperature, humidity. Whilst it might be in a controlled environment, like a clean room, it still gets affected. So, yeah, through training, but more importantly, through having equipment available that has those facilities on it to be able to replicate what works is very important. I think moving on to that variation and adhesion performance, obviously you can get all the machine set up correct and the materials running through correct. But where there's extra tension pulled in to a material, either in the coating process or afterwards, that can affect the adhesive molecules.
Yep.
Phil, can you just touch on the solution for that one?
Yeah, if you're kind of introducing too much tension into the materials, you're disrupting the molecules of adhesive that have kind of stabilized in the coating, and you can, if you're stretching it too much as well, the coat weight is not going to be uniform. Right. So it's very important not to overstretch materials, and if you are having issues with varying adhesion performance, it's always a really nice facility to be able to check and confirm your coat weights. And fortunately at DRYTAC, we have a lot of experience of this. But for converters as well, it's a really nice facility to have, and you can identify a potential problem very quickly. So to have the facility to check coat weights and check consistency is a real advantage.
Sure. So that sort of testing phase is vital in the prevention of this.
Yeah.
Great. So, I mean, I just want to sort of loop back and kind of go away from this for a second. I mean, you've both combined got an extensive amount of experience within this. Do you both feel over sort of the last couple of decades, and I mean, especially Phil, 25 years within adhesions, how do you feel the processes, machineries, adhesion advancements, how do you feel that's all changed over the last 25 years and 10 years and so?
Yeah, for me, from a converting side, everything has improved. Yep. Obviously, with a converter, we're bringing in materials from a supplier, and as their equipment's improved and our equipment's improved, that whole tension challenge is being greatly improved. That's for typical everyday running. There are obviously still new products that come through where you want an extra high island in something, or some kind of slight angle on a top layer, for example, which takes a completely different set of skills and knowledge, if you like. But as an overall thing, certainly.
Brilliant, great. And Phil, so your take on sort of the advancements and how they're critical in sort of preventing these type of issues?
Yeah, I mean, there have been from our side of things a lot of advancements on the adhesive side. Yep. And more products being developed that are more environmentally friendly, and a lot of advancement in hot melt adhesives and water-based adhesives, whereas traditionally these technologies haven't been as good as solvent-based adhesive. But as companies have developed these products, there's a lot more choice these days than there was 10, 15 years ago.
Yep, brilliant. Oh, fantastic. Thank you. Well, I mean, thanks to the audience for sticking around. I mean, that's 15 minutes of in-depth answers and coverage. So thank you. What I quickly wanted to do now is sort of open up a quick discussion, an option for our viewers to send through possible questions around this. I just want to open this up now. We're going to do like a little sort of 30 minutes of silence. I know that's kind of the trick to get people to talk. Me personally, I don't do very well with silence, but anyone now who's on it and has joined and they do feel they've got anything that is necessary, please fire away.
I think, yeah, just on this as well, you just have to type in the box and leave it, and it pops through to the admin, so you don't have to hit enter or anything. My 10 seconds of silence didn't last very long.
Yeah, I'm trying to. They say it's best practice to try and draw information. I'm going to give it another five more seconds, 10 seconds of awkward silence, and then we can push on. Brilliant. See a couple have come through. Fantastic. That was way too quiet and awkward for me, so thank you. Right, guys, ready to push on?
Yeah.
Fantastic. So again, this is our next issue is release liners, and down the line, I want to sort of pick both of your brains on a few topics here. One of the issues, and I'm sure everyone on the call will have noted this, is the components falling off, and this is during the journey of the manufacturing line and whatever process, and there's a variety of reasons as to why and how we can avoid this, and the liner not being stable and the components often distorting, and then obviously the release liner is an expensive part. So how and what do we do? Is this the process? Is this the material to reduce these costs and without sort of affecting the project in itself as a whole? And then the components remain stuck to the liner, and I guess this is Phil, I think, where we can kind of touch base on the next slide. And what is this? Is this the pressure of which the liner is applied to the following material, or is this the adhesive that has been used during the process? So moving on to solutions, guys, take the floor. Let's start off with components falling off. What do we see as the solution? How can we avoid this?
Yeah, that's good. I think on this one, it's very important that as a converter, we're getting an understanding of what the customer's process is. So this is where providing components on a roll, and then they're going through the customer's production line. And it's critical that we're involved at an early stage. We're on the customer site and seeing that process, what path the components are going to take, what angles, what forces they're going to be subjected to ensure that we can then get the correct level of release, to ensure that the components don't fall off. But obviously, then is a fine balance with 0.4 there of components remaining stuck to the liner. It's all very well doing a very tight release, but then if there's a robotic arm, for example, on the line that's taking a component off to place it onto another part, that release liner needs to be able to let go of the part. So for us, it's very important to be very much on the customer's shop floor, if you like, and seeing what's happening with the parts, and then from there we can take it back. We can work out what levels of release that needs to be.
Sure. So, I mean, I'm just going to quickly interject here, Matthew. So when it comes to prevention of the components falling off, now, is this the manufacturer's responsibility, or do you just sit back and say, right, okay, I get it, this is the client's requirements, we're just going to go ahead with it knowing that there's going to be issues around this, or is this when the manufacturer steps in and provides sort of a solution, a bespoke solution to prevent this going forward?
Yeah, exactly. We certainly don't step back and just say we'll find out. That's why we very much like to be there and see it and witness it, trial it, and ensure. And then obviously we can work with release liner companies to ensure that we're all working together to get that right result. So we can then put forward what's going to work best and ideally first time. On the waste footprint, I think ourselves and DRYTAC as well, I believe. Phil will work with a company. Do you want to cover that, Phil?
Yeah. We work with a company and PolarSeal do with a company based in Swansea called Teclan. And
That's right.
Teclan have developed a process for cleaning release liners, which then allows them to be reused and saves the product going to landfill, and also the cost of the product going to landfill as well. Obviously, this is a big issue for the industry is disposal and recycle of release liners, as in most cases they're a waste product. So we're very hopeful that more companies will get involved in this area in the future.
Sustainability within every company is becoming more and more of a focus. One thing that I just wanted to elaborate on there, Phil, is sort of the cleaning of release liners and putting them back into production in the manufacture process. Do you not feel that, is there ways to avoid this? What's your opinion on that? Do you think that will affect the performance of the liner?
Well, they obviously they have a full quality control process, and the way the materials have been cleaned and tested afterwards do give you a consistent performance. I think the only issue with the materials is that there will be more joins in the rolls than there would be in fresh virgin material. But depending on how you use the materials and what you're using the materials for a lot of applications, this doesn't cause an issue.
Sure.
But to be able to have a circular economy and reuse waste materials is obviously a really good thing.
Oh no, I completely agree, and it's definitely one thing that we're trying to work on as well is sort of being a bit more sustainable and sort of aware of what's been happening to the environment, and I think every business should play that part. Phil, I'm gonna bat something back to you here in terms of the components stuck to the liner. I think one of the big things here is it could be the adhesion.
Again, if you're having issues with components falling off or not releasing from an adhesive, obviously that interaction between the silicone coating and the adhesive, something isn't right. Again, if you have facilities to be able to test the peel release value of your release liner and check that is within specification, and also if you have facilities to test adhesives for coat weight and peel release as well, you can identify whether there's any inconsistencies. And if you have those facilities, again, it allows you to identify problems relatively quickly.
Brilliant. All right, fantastic. Thanks. And kind of something within this, but remaining on sustainability, and not really a question for you guys, but more of a fact. I had an interesting conversation with someone a couple of months ago, and maybe you can provide me your opinion on this, is sort of the biodegradable, could be release liners, medical products. And I mean, this is a tricky one. When will this come into play? If it will come into play, is this 20 years down the line, 30 years down the line? The application selection of materials we've got to be so careful of when sort of, I mean, Matthew, you would know, when manufacturing medical devices. What is your guys' take on this? Obviously, we don't want to spend too much time on this. We want to move on. But what is your take on biodegradable materials?
Yeah, I mean, like say in the medical industry, there are products being introduced, and providing they've gone through the correct process and they're back to the clean state, the molecules, etc., are back into a previous form, then I guess that covers the recycling. But in terms of biodegradable, I think there's probably more technology. Obviously, we're seeing quite a few new films coming out that are biodegradable. But there will be significant hurdles to get through.
Yes, that is it. Do you think this is a bit of a stretch, or do you think we're pushing the barriers here a little bit?
Nothing's impossible, I don't think, when we see what goes on. So
great, we'll hold you to it. Let's host another webinar in a few years and we'll bring it back. Right, so again, we're going to go through this awkward silence, guys. It's going to be a quick one. Again, I see quite a few questions are coming through here, and we will attend to them at the end. Are there any questions about liners? Please, a little bit of awkward silence, and we'll push on. Brilliant. Okay. I see his numbers come through. I'm getting a bit too comfortable with the silence there. Get it in the next 20 minutes of just sitting looking at each other. Great. So let's move on to tolerances. Again, I'm not going to bore everyone with reading this out word by word. But number one, repeat orders. So no matter what documentation we take, the setting up of the machinery is quite an issue. Then sort of ordering the same materials with the same suppliers, laminating wovens and non-wovens, as I'm sure we all know, is a tricky business. And then adhesion seems to be affected by warm weather. And again, this kind of relates back to the sort of whole temperature, storage conditions. And I'm sure Phil and Matthew can elaborate on these with sort of in-depth knowledge. So do you want to take the floor, start off with sort of repeat order and machine setup? What is the common issue, and Matthew, what would the solution be around this?
Yeah, sure. Probably goes back as well to some of the discussion we had around the tensions and having that set up. So obviously, in the medical market, repeat order is very much what it's all about. Regular product going through, and especially in our situation, we don't have production lines necessarily set up just to run one product day in, day out, although we do have several of those lines. So it's very, very important. Again, it comes back down to the recording of those initial validation trials, the settings, the tension settings, the dimensions, and the actual location of every single cutting head and unwind the material, rewind, and those detailed in drawings that are then plated exactly as they are on the machine. So repeat order then becomes very much a case of switching between jobs, doing it as per the drawing. It's like take a car manufacturing line. Every single car has a slightly own specification, but the base of it is the same.
That's right. Yeah. So, do you think, just quickly pushing on that, do you think with over the years, there's been advancements within the industry, machine setup? I don't know if that's even sort of knowledge transfer through to operators on how to reduce that downtime and switch between sort of manufacturing of products?
Yeah, certainly. Big advances in that area, and where, say, 20 years ago, it would have been a lot more gear driven. Now everything's much more technical. It's servo driven, so it's driven by computer, and those settings can be logged and set and then just recalled back up. So yeah, very transformational in that area.
Fantastic. So moving on to sort of the material quality variances, and I'm sure we're all very much aware of this. How much does that have an impact, and what can we do to avoid this?
Yeah, it does. Obviously, again, where we're bringing master rolls material and then processing them through our lines, if we're not working closely with suppliers with those materials, ensuring that whatever's sent to us is according to our specification or our customer specification, then immediately that will start causing issues out of tolerance, and as well as important to have the strict quality checks on incoming goods. But Phil, how from the other side of it, how do you?
I think training and experienced operators are very key, because every single role will be slightly different. The tolerances either in the thickness of materials won't be exactly the same. The any coatings or adhesive on there will not be exactly the same. So you're kind of reliant upon the experience of the operator being able to adjust the tensions to that particular role. All materials will be similar, but each role will be slightly different, and it's really down to the experience of the operator to be able to run that product effectively.
Cool. So a bit of avoidance through experience, right?
Yeah.
Fantastic. Great. Okay, perfect. And let's move on to sort of the curling edges again, sort of very common. Do you both want to sort of elaborate and then also talking about the adhesion of variances?
Yeah, sure. It comes back to a bit of tension, might be in the initial material again. And covering that point that Phil said on experienced machine operators, which is very important, but obviously you can't just get an experienced converting line machine operator very readily, and it does take a lot of training. Curling edges and affecting the tolerances is a big thing, and again it does come back to what are you doing to reduce tension, what are we doing to reduce incoming tension in master material to prevent those curling edges, which obviously then make the product undersized. And incoming good QA and the process of getting that through the machine to prevent that and ensuring correct tensions will reduce that effect on curling. And I think it also is affected by point 4 there as to the adhesive variance. So if there's a variation in coat weight, that can cause the material to be pushed through the machine slightly wrong angle at a certain point because the rollers are gripping more on it in that area, which will give a curling edge and then move the product out of tolerance. But what do you say on the adhesive coat weight and then also the 0.4 there variance due to weather? Phil, I know you covered it a bit, but
yeah, I mean at DRYTAC we will normally bring in our raw materials before coating them a minimum of 48 hours, and it just allows that material then to be consistent, and you're consistently processing at very similar temperatures. Again, materials will contract and expand, and this can introduce inconsistencies in tensions and make materials more difficult to run, and also how they rewind back up again can be affected. So it's very important to have your materials acclimatized prior to putting them down a production line.
Yep, absolutely. Yeah, just touch on that. Appreciate time's running down here. That acclimatizing, and it goes back, probably cover off one of the questions that came through at a certain point, which should help to answer that question around how does PolarSeal control temperature and humidity. That is very important for us, and our warehouses are very much temperature monitored, and then, but most critically, is giving the products the time in the final processing room, so the clean room, where they acclimatise to that temperature. Obviously, clean room is temperature regulated anyway, and humidity is monitored. But providing they have enough time to get into that state, then that overcomes a lot of those issues. So That's good. I mean, tolerances is a massive subject, and I've certainly seen over the past 10 years they've become tighter and tighter and tighter with new technology and customers' demands wanting and needing much tighter tolerances, and it's becoming much more of a focus for us, especially over the last 5 years, in the processes that we develop in manufacturing products to ensure that every new piece of technology is going to help just improve that tolerance.
Brilliant, thank you. Yeah, and I mean, sort of the advancements within the current processes to achieve that. I'm sure when we have another webinar down the line, hopefully we can develop on that. I can see all the questions coming through. We'll answer that at the end. I think we're closing in on finishing now. So, guys, I just wanted to again thank you before we go into the Q&A. It was incredibly insightful. Thank you. We've had a few questions come through. One of them was, have you ever heard of any liners being made from natural product such as bamboo? Initially, I read that as shampoo, and I just had to kind of read it back a little bit. But I think the coffee's kind of kicking in. So, I mean, what is your take on that?
I've not come across bamboo, but there are a number of release liner manufacturers now offering recycled paper release liners, so which I think are out in the marketplace now. So these are available.
Yeah, I don't think I've heard of it exactly in terms of release liner, but I would be very interested, whoever sent that through, if you could let us know if you have heard of it, because that'd be
certainly interesting. Good read. Yeah.
See, there are a number of new natural filmic type materials that are starting to come into the market as well, which are a lot more environmentally friendly than materials like polyester or polypropylene.
Yeah, no, exactly. Great. And one of the other ones I think we were talking about, we touched on it, was biodegradability within materials used. See someone has come through saying biodegradable is available now. I know, I mean, this would probably be within a lot of materials. Would this not be sort of very specific to the, obviously the requirements of the drawings and the specifications coming in for the product? Or can these materials be used on anything?
Obviously, there are biodegradable materials out there now, and there are biodegradable adhesives as well. I would say on the adhesives at the moment, the choice is fairly limited, but this is very much a big area of development for all the adhesive manufacturers at the moment. And I think over the next few years that the availability of these materials will grow and grow.
Brilliant, fantastic. So Matthew, is there anything? Sorry, I just butted in there.
Cool. Yeah, I mean, they are available, and I think where it's going to be a potential challenge or where there's more development required is when it's a wound-facing wound contact layer, if you like. Obviously, and aside to that is the cost, but so you can't put a cost on the environment. So I think it's going to be something that we see more and more of, and we'll be very glad to be part of.
Brilliant. Yeah, and I'm glad you just brought that up because the questions come through. Are you aware of any plans for a recyclable liner that does not have numerous joints?
As I say, I think it's Mondi who are producing the recycled release liners. I don't know if it's possible to then recycle a recycled liner, I guess, at the moment.
Yeah, I'm certainly not too aware of them without a lot of joints. I think the company you mentioned earlier, that's taking both our release liners and DRYTACs and many others. Where they're reusing them, typically, I think, goes back into an industrial applications.
Yeah.
And I think their cleaning process does reduce the number of joints quite significantly. So, yeah, I mean, we can drop a note out on that company. They're very, very helpful.
Yeah.
Brilliant. Well, yeah, thank you very much. I know we've got 5 minutes left. So again, I know sort of everyone's got things to do. I see one more's come through here. Is not ethically sourced more important than biodegradable, as many medical products require incineration? Yep, I believe so.
Yeah, that's a very, very good point. And thank you, obviously, to all these questions. Thank you for that point in there. I fully agree. It's very important, ethically sourced, and in the medical market, it probably is a safer route to go down currently. So yeah, it was a very good point. Thank you.
I think ethically sourced and sustainable materials are where the focus is. And if materials are completely sustainable, the plastics are not sustainable. So all the more environmentally friendly materials that are being developed, sustainability is a really critical part of it all.
Brilliant. Great. And then just last one. Sorry, we've got a few others here that we don't really have time to answer. So how does PolarSeal test adhesive strength of incoming products?
Yep, that's good. Obviously, we require certificates of analysis from the adhesive suppliers, roll good suppliers, and that has their testing. But to double ensure we're okay, we will typically do peel testing, and that's normally we'll do batch peel testing before, and then once we've made the component or the product, there'll be further peel testing as well. But obviously we want to catch it before it's been done. So it's kind of a double security, if you like, making sure that the supplier is saying that they've done their testing and it conforms and it's correct level, and then we're just kind of backing that up, making sure that we are working with what's correct for the application.
Brilliant, great. Thank you very much, both. So I'm going to have to cut it off there. Kind of sort of hitting the time limit here. So
I was just going to say, any of the questions that we haven't had a chance to answer, we'll just wanted to assure you we'll get an answer to you offline.
Yeah, exactly. Great. Yeah, we will do. And if there's sort of anything further, we really appreciate these. If there's anything further, please email us at inquiries@polarseal.net. Phil, if you've got any questions for Phil, are there any contact details for you?
Yeah, I mean, you can contact me through the DRYTAC details there.
Brilliant, great, fantastic. Anyway, so thank you very much both for your time. Phil, thank you very much. For everyone who has joined, thank you very much. Matthew, again, thank you to everyone for your time. We hope that we have provided some sort of insight here into sort of common issues that we've demonstrated today. And again, if there's anything else, please don't hesitate to get in touch. So again, thank you very much, and have a lovely day. I think we got through a webinar without talking about the football. So
nearly.
All right, brilliant. So yeah, fantastic. Thank you very much, everyone.
Thank you, everyone.
And have a great day.
Be in touch. Thank you. Goodbye.
Bye.
Goodbye.